Vulnerable Wetlands and Stormwater Management Planning. Part 4, GIS Maps, Vulnerable Wetland Index, and Subwatershed of Interest. This is the fourth in a series of 6 Vulnerable Wetlands and Stormwater Management Planning presentations. In this segment, we look at how GIS maps can be valuable municipal planning tools. We also discuss how to develop a municipal GIS index map as an overview of subwatersheds and impaired waters in the community, and then how to use the index map to create a separate page for each subwatershed that falls within the town boundaries. Stormwater is a key consideration in any effort to protect and restore vulnerable wetlands. Stormwater control is also an integral part of federal and state requirements to protect and restore water quality in watersheds throughout Massachusetts. We designed GIS maps using a healthy watershed planning approach to demonstrate how the maps can be used by communities to identify cost-effective ways to simultaneously protect vulnerable wetlands and comply with stormwater requirements. GIS maps that are developed using relevant technical, landscape, and resource area data can create functional stormwater management planning tools to help communities reduce the impacts of stormwater discharges to all wetland resource areas. They are useful for analyzing how to meet the pollutant reduction levels specified in a TMDL and how to meet the federal requirements regarding municipal separate storm sewer systems, typically referred to as MS4s. GIS maps can be designed to visually incorporate baseline planning information, such as watershed boundaries within the community, outlined in white on this image, the location of wetland resources and impaired waters, shown here as red, yellow, and orange streams and water bodies, and the mapped location of stormwater outfalls, shown here as yellow dots. This watershed approach allows planners to easily identify which waters are impaired and identify which subwatersheds could provide the best stormwater compliance results with the least amount of effort and expense. Once a subwatershed is identified using the index map, GIS tools combined with an EPA Healthy Watershed approach can facilitate a holistic long-term plan to remediate water quality issues, restore the designated uses of a water body, and sustain the water quality over the long term. This map illustrates the location of vernal pool clusters and headwater streams in the subshed landscape and allows planners to visually determine how close the vulnerable wetlands are to stormwater outfalls and their proximity to impaired waters in the subwatershed. The beauty of a healthy watershed approach is that the remedies available to a community to meet the state and federal stormwater guidelines are the same remedies used to protect and restore vulnerable wetlands. And because the wetlands are hydrologically connected to impaired waters, improving and preserving vulnerable wetlands simultaneously addresses removing and reducing the pollutants of concern outlined in a TMDL. So the goals of meeting stormwater standards and preserving and restoring vulnerable wetlands are synonymous and can be accomplished simultaneously with the same municipal funds. Looking at critical areas from a watershed perspective makes it easy to see where our public resources, like Zone 2 to a public water supply, are located in the landscape, and the potential impact that the impaired waters may present to the public resources. The impaired streams shown in red are located at the boundary of a Zone 2 to a drinking water supply and likely contribute directly to the recharge of that supply. In addition to using GIS maps to identify water issues, the technology can also be used to identify potential solutions. Massachusetts stormwater standards require that stormwater discharges near critical areas employ specific source controls and pollution prevention measures for managing the quality and quantity of water being discharged. Hydrologic soil groups A and B typically contain a low percent of clay and high percent of sand in the mix. Water flows unimpeded through these soil types, which makes them ideal for stormwater treatment and infiltration. So adding the hydrologic soil groups A and B to the map highlights locations near to stormwater outfalls that may be advantageous sites for stormwater retrofits or stormwater treatment and infiltration that get the best return for the town's efforts and funds. In this image, the light tan represents hydrologic soil group A and the darker tan group B. For this last map design, we included data on pollutant-loading land uses in the watershed that may provide insights as to potential sources of water quality impairment and suggest land use changes that may lead to pollutant reductions. MassGIS's extensive mapping resources enabled us to develop a town-wide overview or index map showing the location of subwatersheds, in this case white outlines, and impaired waters within the community. The town index map is designed to help planners visually spot subwatersheds with impaired waters and areas of concern in the community. The subwatershed of interest map contains the subwatershed boundaries, which are highlighted, and impaired water categories, as in the overview map, but narrows the focus from the town-wide perspective to a limited land area in which to investigate vulnerable wetlands and stormwater issues in further detail. 6 additional detail maps have been developed for each subwatershed that falls within the corporate borders of the community. This town index map shows the Neponset River subwatersheds that fall entirely or partially within the town of Sharon corporate borders. Subwatersheds are confined drainage areas that typically have a single outflow and provide a convenient and discrete land use planning area within a town. For purposes of our grant, each subwatershed is named according to the main water feature within that drainage area. If 2 or more subwatersheds have the same water feature, an additional identifier is added to the name. For example, Pequod Brook is used in 2 subwatershed names. One is named Pequod Brook Subwatershed, and the other is named Pequod Brook Beaver Meadow Brook Subwatershed, reflecting the next largest water feature. The overview map also identifies waters in the town that are categorized as impaired in the Massachusetts Integrated List of Waters. Impaired means that the water body segment is not attaining one or more of the designated uses defined by the Clean Water Act and are not meeting the Massachusetts surface water quality standards. This map serves as an index to design subwatershed of interest maps described below. To design the overview map, we started with the USGS topographic maps with 3-dimensional relief as a base layer. Then added the major watersheds layer with an outline defined in green as an overlay to the topographic relief. The MassDEP hydrography is added to illustrate water features in the community. And the Massachusetts town boundary layer is used to outline the corporate limits of the community. The MassGIS statewide drainage subbasins data layer is clipped to the selected watershed boundaries to include subwatersheds that are within both the selected river basin and the town boundaries. Each of the subwatersheds that are partially or wholly located within the town are assigned a name according to the main water feature as discussed above. The MassDEP 2012 Integrated List of Waters map for the Commonwealth provides a spatial representation of the river, lake, and estuary segments in the state where water quality has been assessed and assigned to one of 5 categories that characterize the status of water quality and the ability of that segment to attain the designated uses under the Clean Water Act. Adding the impaired waters data layer to our map design visually marks the location of problem areas within the town. A planner can focus on subwatersheds with the greatest impairment and on subwatersheds where the town can most effectively address stormwater-related issues. The maps depict categories 4A, 4C, and 5 to facilitate identification of impaired waters. Note that there are no waters listed in category 4B, so this category is not displayed on the map. The last layer added to the index map is the town-mapped location of stormwater outfalls. This data illustrates the proximity of stormwater outfalls to the impaired waters, which helps to identify potential non-point sources of pollution contributing to the impairment of the stream or river. The town-mapped stormwater outfall data layer is typically available from the community engineering or highway departments. A legend and scale are added to the overview map to identify the symbols and improve readability. The index map can now be used to develop a series of detailed maps entitled the Subwatershed of Interest that we will describe next. Using the index map and the data-driven pages function in ArcMap, we created a separate subwatershed of interest map for each named subwatershed within the town. A global layer or locus map was added to the main map page as a reference to the location of the subwatershed of interest within the river basin and within the town. The subwatershed of interest map contains the same drainage basin boundaries and impaired water categories as the overview map, but narrows the focus from the overview to a single subwatershed, highlighted here in yellow, for which additional detail maps will be developed. Here are some examples of the subwatershed pages that were created. The left map is the Beaver Brook-Massapog Brook subwatershed, and the right map is Devil's Brook-Massapog Brook subwatershed. You can identify each of these subbasins in the town overview map. For each subwatershed of interest, 2 sets of GIS maps were developed to provide further detail for planning purposes. The first set is Subwatershed of Interest Map Type 1. The base for this map was designed using the 2011 Orthophotos with overlays of the Index of Ecological Integrity and the mapped stormwater outfalls. Relevant technical information was added to the base map to create 3 separate map images. Map 1A includes vernal pools, vernal pool clusters, and headwater streams that were developed previously as graphic layers. Map 1B overlays the public water supplies and other critical areas from the wetland stormwater regulations, and Map 1C contains land use types with higher pollutant export loading rates. The second set is Subwatershed of Interest Map Type 2. This map type has the same information as Map Type 1, but in this case, the base map was designed using hydrologic soil groups instead of the Index of Ecological Integrity data layer. We'll look at how to develop these maps in detail in the following segment of this presentation. For additional information regarding vulnerable wetlands and using GIS maps for stormwater management planning, please contact Nancy Lynn or Alice Smith of the MassDEP Wetlands Program. Our email addresses are nancy.lynn@state.ma.us or alice.smith@state.ma.us. References and links for vulnerable wetlands presentations can be found on the MassDEP websites under Education and Outreach. Vulnerable Wetlands and Stormwater Management Planning presentation is funded in part by a Federal Clean Water Act Wetland Program Development Grant from the United States Environmental Protection Agency, Region 1.